not gonna ask you.
Okay, guys.
I'm gonna go.
All right. So the equations for lenses are the same as the equations for mirrors, and all the variables still mean the same thing. You guys, I assume, don't need me to write them all down again, or would you like me to? Very good. Okay, the positive and negative things are, again, essentially the same. The only difference is, with lenses, the object distance can be negative, but for our purposes, we're going to make it always positive, just because it gets weird if the object, you're looking through a lens at something and the object's on the same side as your eye.
What?
Like, it's possible you can see, like, if you held like a little tiny like plastic thing here and look through, and the lens was right here and look through it, you can see the image of that in the lens. But it gets kind of complicated to deal with stuff like that. So we're just going to always say the object's on the other side. Alright. So let's do a couple of these real quick and then we'll be done. And then you guys will do the rest on your own. So an object, number one, an object is placed 24 centimeters in front of a converging lens of focal length 15 centimeters. Find the image distance and magnification. Also state whether the image is real or virtual, upright or inverted, larger or smaller. Okay, so how can we find the image distance? What equation do we use?
1 over f equals 1 over d1. Yeah.
Alright, what's the focal length? 15.
Way to go.
Is that positive or negative? Is it converging or diverging?
Convergence is positive.
So it's positive. Image distance is what we're looking for. And what's our object distance?
24.
Alright. So now, to find DI, we subtract 1 over 24 from 1 over 15, and then take the reciprocal of that. What do we end up getting?
40.
40? So our image distance is 40 centimeters. Questions about that? Now, how do we find the magnification?
M equals di over do.
Yep, negative di over do.
That too.
So we get negative 40 over 24. And what's our magnification?
1.7.
One
Negative 1.7.
Negative 1.7. So that means the image is 1.7 times larger than the actual object. So what do we know about this image? Real or virtual?
It's real.
Well, it's real.
Is it negative? So
Converging, so
This is what we're looking for.
oh, yeah.
Inverted or upright?
inverted.
Inverted.
Right.
That's
Inverted.
negative.
That's negative.
And larger or smaller? Or larger. Right. Perguntas?
When's this test happening?
No, it's
No.
good.
What?
Most of you
When's this test
testing.
happening?
I think we're gonna have a quiz over the math on Friday.
What?
Love it.
You guys
Like
get
group quiz or?
probably individual quiz.
Love
Just the
it.
math.
Four tests on Friday. Okay.
Do we really?
Let's take it Thursday.
I'm not gonna be here.
Okay.
Well,
Well,
gotta do the test now.
okay.
I can't look around.
Love you.
Can I erase this?
Yeah.
Alright.
Yeah, I made it. I made the worksheet. Yay!
Alright.
I want to be.
Now
Shh. Number 2. An object is placed 14 centimeters in front of a diverging lens of focal length 11 centimeters. The object is Kira, who's been shrunk to be 21 centimeters tall. Find how tall the image of Kira appears. So you've got 1 over f equals 1 over di plus 1 over do. What is our focal length?
11 centimeters.
11 centimeters. Is it positive or negative? Positive because it's
Is that a negative?
negative because it's diverging. Make sense? We're looking for our image distance. And what is our object distance?
Well, that's 14 centimeters. It is 14.
14 centimeters. Alright, so now subtract 1 over 14 from negative 1 over 11 and solve for DI. Is there ever a way that the image distance could be positive for a diverging lens?
No.
No. So with a diverging lens, you always get a virtual image.
I think it's negative 6.16.
Sounds right. It is 6.16 centimeters. So is our image real or virtual? Virtual. I'm going to do DI over DO equals HI over HO. So yeah, you get negative 6.16 divided by 14. And the whole thing is negative, yep. And HI over what's Kira's height?
21 centimeters. 0.
You're pretty small.
So cross multiply and you get
No,
feel free to resort to physical violence.
You sound like a monkey, bro.
Alright,
9.24.
9.24. Alright. If this is something else, if the image height is positive, that means it's upright. Does that make sense to everybody? So if you get a negative image height, that means it's upside down or inverted. But that's the answer to this one. Any questions about that?
I have a question about that.
Hi, Miss Arbor.
Hello, Mrs.
Can I get
Alba.
something to Sean Brown?
Sure.
I'm gonna have clearly already interrupted.
You're on video. Would you like
We're
to be on
actually
I'm on video?
Oh, she loves it.
camera? It's CJ.
Hello. It's who?
CJ.
Like, as in Sean and Julia?
Yes.
CJ.
Hello, Eagles. Welcome to the land of night. Enjoy your class. I teach drama.
And
And scene. Oh, I should have done that.
perfect. Come see the musical.
Thank you, Ellie. She's
Come
trying
out and support.
She's trying to redeem herself. These are for your mom. These are her sponsor tickets. Can't lose them. Very important.
Wait, how much? How much? Right now, how much?
Come see the musical.
They're $10 pre-sale, but they're $12 at the door.
I'd pay 100 to see that.
Not $12 at the doors.
Ellie's trying to redeem herself. Do you
She
want
got
to
mad
tell
at
why?
me. We were in
It's
June.
CJ.
And
What show
I
are
was
you
like,
doing?
oh,
What
Brown,
play
and
are
I was
you
like, what's
doing?
the
And I
show
was
again?
like-
She's like, what show is it? And like, you wouldn't think that I stole Jack or something.
She did. She stole his heart.
Have a good CJ.
It's musical.
I apologize again.
Musical heart.
It is.
I almost.
Be safe.
Okay. And physics. Okay, you guys have any questions over any of these?
No, we're good.
Okay. And number 3 when it says describe the image, that just means like real or virtual, inverted, upright, larger, or smaller. Does that make sense?
Yes, Mr. Ten.
Alright. I'll put the answers in front of Chloe and Kira again.
Have a great day. What did I say?
Be safe.
Put him in front of Sean and Alex.
Yeah, that sounds good.
Of course, Sean.